Welcome to Pavithra Laptop Care. Now what are the voltage we got? We got 19 volts. V means it's a 19 VB RB plus. Second one is 3 VL and 5 VL and RTC section. See, in today's topic, so clearly I will tell you what are the voltages and what are the signals you will get on the motherboard. This is very important when the board will be in dead condition. Okay, let us start. Here is the V in section. I already explained you, but now I am going to explain you in case of short, 19 volts short, what will be the root cause. Okay, see, this is most important point. Here is a coil. Here it's a very small coil but makes big problem because in many cases I found this, because of this coil your load won't take much. When you put the RAM, that time it won't take the load, it will trip, it will off. When you remove the RAM, it will on. In that case, this is the main culprit. Okay, means this is the main suspect component. So this you need to replace it and check the load. This is number one. Second thing is you need to check all bypass filters, means bypass capacitors which is connected in between the positive and the negative. Okay, see, in this path, this is a V in section, right? In V in section 1, 2, 3, 4 capacitors are there. In case anyone are leak or short, in that case 19 volts path you will get ground, means it's a 0 volts. See, this path, what are the components are there, those one by one you need to check. First you think what could be the reason. Here is the CLR. In case 19 volts path short, then till here you will get the 19 volts VB, right? So this 19 volts VB all over the motherboard will go. Now I will tell you exactly where it will go and what are the components you need to check thoroughly, because this is a fact, it's complete section I am going to tell. See, here 19 volts is this is V in section. This is connected to this MOSFET. In case of MOSFET as short, then here you will get 19 volts, but the battery won't charge or this one won't switch it on, because here you won't get the gate voltage, so it won't function. In that case also you will get dead. Here capacitors are there. In case of capacitor short, here you will get 19 voltage but not 0 in 19 path. Okay, here CLR, if you are getting short here, in that case this charging IC may be the issue. Okay, one by one I am going to tell. See, here this path is connected to the ground. Here may be the issue. What are the capacitor is connected to the ground, that path you need to check compulsory. But before that, some hint I will give. Need not to remove all the capacitor at a time. So what are the checking point one by one? Once it comes, the stage will comes, that time I will tell you. Okay, now V in path over, it's a diode, maybe the issue. In case of diode short, then charging IC won't turn on. Maybe here in this path may be having the issue. In that case you need to replace the diode or remove this, or you can put the jumper also. That's depends on condition. Okay, so here in case of CLR short, here is the suspect one, but here this one is short, so here 19 volts path won't get short. Only the CLR you will get the 19 volts or lesser than that, but your charging IC won't work properly. Okay, because gate you won't get. Here if it is short, this capacitor short, 19 volts path you will get instead of 24 volts in the gate. Okay, next, see, the CLR voltage become 19 VB. The trick I told you, no, you remove this CLR, then you need to check this side or this side has the short. In that case, you need, in case 4 and 3 section has short, you need to check all 19 VB path. In case this side has short, you need to check here to V in section. Okay, now assume this 4 3 having short, then you need to check this 19 VB path. Okay, here it has connected to the MOSFET. Which MOSFET? Discharging MOSFET. This one is connected to the battery section. Battery section has the ground, capacitor ground. See, here this capacitor has issue. Okay, here one CLR is there. Here also these capacitors are connected to the ground. Maybe here or maybe here, maybe the issue. Okay, in case of here issue, you won't get the gate voltage properly. 19 volts or battery voltage you will get. Okay, this is the main suspect points. Capacitors not here. In that case, you need to replace, you need to remove this MOSFET, and then you need to check this path short has gone or not. In case short is continue, then you need to check the 19 volts path. Next, where it has connected, that you need to check. See, here 19 volts path has become 19 VB underscore charge. Here 4 capacitors are there. This may be the suspected one. In that case, you need to remove this coil, and you need to check the short is here or here. In case of here won't be there, then it's easy to remove the short, because these capacitors you need to check. And here high low MOSFET also is there. In case of this MOSFET also short, then also you will get the 19 volts path short. In that case, you replace this dual MOSFET or remove the dual MOSFET, and you can check first. So major components you need to remove first, and then minor one. Okay, here 2 coils are there. First you remove this one. In case of this side short, you remove this MOSFET, and then you can go for this one capacitors. See, here is a low MOSFET. Low MOSFET source will be the ground. Okay, that's why I am telling you, you remove this and you can check the short. In case short this side, so this capacitor may be the faulty. See, 19 volts will go to this section also. This high low MOSFET, it's a dual MOSFET. Here it's a 3-5 section. That's why the named as 3-5 section. In case of 19 short, you need to remove this coil and you need to check the problem with the 1 or pin number 2. In case of pin number 2, here is the capacitors. This may be the short, okay, or leaky. Here high low MOSFET, its low MOSFET is connected to the ground. Here also may be the issue. In that case, you need to replace the remove this MOSFET and you can check the path. Okay, and here main capacitor also is connected with the coil. See, the 19 volts path has given to the supply to the 3 volts IC. Here there is no suspect, because in between you have a resistor. Okay, it has gone to high low MOSFET of 5 volts always section. So same thing, you need to check this capacitor. Before that, you need to replace or remove this, and you can check. See, all capacitors are there. This one is converted as DDR, means it's a RAM section. Here is the high low MOSFET. See, once V in voltage will come here, what you are seeing here, it's a high low MOSFET. All high low MOSFET will be active. Okay, but it won't start working, because the standby voltage will be there till the source, drain. Once here command will come in the phase, then only it will start the low gate and high gate when it actives. Okay, at present it will be 0. The V in section, one more thing you need to observe here, this one is 1 volts prime. Once the supply get this IC, it won't start, it won't give the prime. Okay, prime volts once when it will start, once it get the enable signal. Till now the V in path will have the supply. Okay, here is the enable signal. See, 1.8 power good. If this voltage will come, then only the 1 volts prime will start. Next, where it has gone, see, it has gone here. So here what I told, this coil you have to remove and you check the 19 volts path. Next, here VRAM section, here also the same. This IC, once it receives, it won't start until unless it receives the enable signal. Next, here are the same thing. See, all high low MOSFETs and some direct V in section it has gone. Okay, So this IC may be the faulty, or this section, these capacitors may be the faulty in case you get the short in number one side. In case of after removing this, in case of two side is there is no short, then this side only the suspect components, only this capacitors and this IC. In case after removing this there is no short, here is the short, again you need to check further. See where it has gone, here is a jumper, you need to disconnect this jumper and then you need to check this side or this side has short. Here in case number one side has short, then you need to check these capacitors. Before that, what I told you, you remove this MOSFET and you need to check the short has gone or not. Next, here is the fuse side. What side? It's a EDP section. A fuse will be there. There also 19 volts path has come. See here some capacitors are given 1 and 2. So these capacitors you need to remove. In case of this capacitor has short, then also you will get 19 volts short. So that's it, 19 volts will be short. Now what we saw, 19 volts will be got over. Now we will check the 3 volts VL. Once 3 volts VL you will get, what are the signal it will carry, what will be the pull up, for what signal this voltage will be the pull up, and the signal, active signals, what are those, we will check. See, once it gets the supply, 19 volt supply, so immediately the 3 LDO will generate. See the pin number 3, you are getting 3 volts here. These 3 volts, what are the signal it will carry? See, here is the pull up for ILIM charge. See, note down what are the signals you will get. ILIM charge, but it won't go anywhere, it will be here only. Here through this pull up PC in 1 AC, okay, it's going to the IO. Through this 3VL, it's going to RTC section. Here is a diode. Pin number 3, it has 3 volts VL. Okay, through this diode pin number 3, so you will get pin number 1 output, that is RTC VCC. It means the PCH receives the RTC section. So RTC will active now. So once it receives RTC VCC, then what you will get? You will get the reset signals. I will discuss this one. So now see power button out. The power button out will carry the 3 volts LDO, but it won't active before pressing the power button. Okay, after pressing the power button only it will active. Next, EC CLR CMOS, it will active starting itself. Okay, next, here the 3 volts VL is converting to 3 volts always underscore EC. Here 3 volts VL is converting to this voltage. This 3 VL is converting as on and off signal. See here one more signal, on and off. Lit switch, but from where it has come, that we will check. Now we got on and off. Here is a test pad. Here BI, it's a battery information, is going to the IO signal, IO pin. Through this VL, 3VL, what are the signals we got? We got VC in 1 ACOK something, right? ACOK 1. Second one, on and off hash, battery information hash, RTC VCC, right? This one. Then what we got? EC CMOS, and ILIM also we got, but it's not moving forward. So here on and off, this one ACOK information we got. This one through this thermal related information also we will get thermal related information, on and off, battery information, RTC, VCC. This one is PCH. Okay, here ECC MOS, and battery out. What is that? On and off button, power button out also we got, but still it will be in off condition. Okay, these are the basic voltage we got. Now through the RTC VCC, what voltage we are getting? This is the RTC VCC section. This is the most important signal, because if you won't get RTC VCC, if you after getting the RTC VCC also, if these sections are not working, definitely your motherboard will be dead, because here PCH will active. The first point is PCH will active. See through what? Once RTC VCC will get, it will start SRT C RTC S RTC SRT. It's a reset signal. It's a PCH RTC RST hash. PCHS RTC RST. So here is the touchpad. Through this signal we will get the CLR me. Through this signal we are getting the CLR CMOS. Okay, and intruder also is there. SMC system bus intruders. This signal also we are getting, and finally once we combine this, so we will get CLR CMOS hash. This signal is going to the IO. Then IO signals we got on and off, battery information. Now EC CMOS hash. Okay, one by one I'll write. On off. These are the IO signals. IO, it's an input to IO. Okay, next battery information hash, battery in hash for IO. Next, just now we got CLR CMOS input to IO, and VCC AC in. Some VCC AC in 1 AC OK something is there, right? That also going to the input for IO. Next, what we'll get? So RTC section over. Through this RTC section, PCH will start. Means it will clear the what is that? RTC section, real time clock section. Next, what we will get? What we got? RTC over. See, at a time here is a crystal. Crystal will get active through this PCH RTC X2 and X1. Okay, this is the positive and this is the negative. Means it's this side and this side, both sides. It's one side and two side. It will active through this resistor, 10 mega ohms resistor. One side it will be floating and one side will be, it's a constant one. Very less voltage you will get in this. So you need to check through the DSO. Okay, next, what we got here? One most important thing I am going to tell you. This 3VL is converted as 3 volts always. Here the first signal, this one actually, the board ID. The board ID also we got now, because the 3VL converted as 3 always underscore EC. So it's a board ID. This also one signal, 1 2 3 4 5, right? Next, which one we got? These are signals. Sixth one, RTC VCC CC. Reset RST signals hash. This 2 SRTC RTC, right? So that also we got. And next, this voltage we will check. So through this voltage we got board ID. right? See, here is the main voltage. Through this we got board ID. Next what we will get, NMI DBG. See, many signals are there which we don't know, right? So next, seventh one, NMI DBG. Where it's going? Maybe to the IO. If this is the IO section, definitely here it somewhere it will be there. Debug signal. See, NMB DBG. This is the IO signal, NMI DBG. Next, NMI DBG. Next, what signal we will get? You need to check. See here, the main signal is lid switch. This is most important one, lid, because if lid is active, definitely your motherboard won't turn on. It should be 3.3 volts, means approximate 3 volts. Okay, if this one becomes 0 volts, definitely dead condition will be there. Okay, this is the clue I'm giving. Next, see, SMB clock 1 and SMB clock data 1. Here is the communication signals. It will start CLK1 data 1. It's a communication channel started. Okay. Next, see, this is the thermal information. pH, VC in 0 pH. This is also going to the IC. VC in underscore pH. Okay, thermal information. See, here is the clue. Actually, power rail, RTC we got, V in we got, battery side we got, B plus we got. This is a 5 volts. It's not used here. 3 VL we got, but here this is the wrong actually. 3 volts always EC. After pressing the power button, it's showing here, but here it's wrong. We got through this 3 VL. Okay, that also I will prove how we got this voltage. Once IO receives the voltage, see here, this 3 VL converted to this 0 resistor 0603 size, that resistor it become this one. So here the particular path what they given, it's a power rail, that is wrong. Okay, next, see, now what are the voltage we got, that I already explained you. So these all are the power supply. Once 3 VL comes, so here number 9, 22, 33, 96, 111, 127, 125 and 67. These all pins should have 3.3 volts, as well as here also one more point is there. Here also you are getting 3.3 volts, V18R. Okay, here these are the ground. See, IO, that's it. Now what we got, the total summary I'm telling. So we got 19 V in B plus or 19 VB. Okay, next 3 VL we got, it's a related signals. What is that? On and off. On off signal hash, it's a 2 IO. Next, lid switch hash, NMI debug something hash. Then thermal related V in pH, then V in AC. Okay, Then what else we got? Thermal over. So DSLR to the IO, right? So next RTC VCC, we got RTC VCC. Using this SRTC RST hash, RTC RST hash. Through this PCH will active, IO will active. Okay, I am repeating this one by one because these all are very important points, so that's why you have to keep it in your mind. So these are the voltage, these are the signals we got before pressing power button. Okay, here is the main part over. Next part is once you press the power button, what are the changes it will have. Just a clue I'll give. In next video we come to know what are the parts we will get. See, now what will happen, now RTC is ready. Okay, now here on and off is ready. This is the signal, and lead is ready, switch W. Next, once RTC on and off, lead and PH, it's a thermal related information, and AC OK. Okay, these are basic voltages ready. It's input to IO. Then from the IO you will get output, what? Power button out to PCH. Okay, power button out and other related signals. That thoroughly we will check. Once you press the power button, here it will be high and again low, it will be again high. Means here 3 volts, here 0 volts, again 3 volts. Then it will become on. Once it on, the active signal pass to the IO. Then once IO receives this on and off, then immediately it will release the power button out. Yes, power button is now pressed. That signal goes to the PCH. Okay, according to this, what it will give? It gives SLP signals. Okay, suspend related signals. That one is S5, S4, S3, S0. S5 to S0 signal will release from the PCH. When the IO send this power button out signal to the PCH. If all voltages and all required IO signals are okay, then only these suspend signals you will get. Otherwise, definitely this power won't get out. And one more most important signal also is there. That one is RSM RST. This one is resume reset. Okay, once you, before pressing the power button, yes, reset signal will happen once these all signals are okay. Okay, after that IO will release that power button out, RSM RST before that, power button out, then it goes to the PCH, and finally PCH will release sleep related, suspend related voltages. After it releases, immediately the IO will release EC on. This is the first voltage from the IO, EC on. Once this EC on will release, so you will get 5 volts always and 3 volts always. Once this 5 volts always and 3 volts always release, then what is that? This 5 volts and 3 volts carryable signals will start. So what are those carried signals and pull-up signals? Those in next video we will check. Okay, if you have any doubt, any queries regarding this, so please put it in comment. Thank you very much.